So today, all the L1, L2s have one thing in common, is that they're completely transparent databases. We do believe that there needs to be a minimum confidentiality in order to drive mass adoption. So if you think about using crypto as your bank account today for payroll or just your savings account, everything is transparent. And this is quite inconvenient because this is not how Web2 works, right? What if you need to be able to hide your wealth? This is something that you just cannot do today in crypto. And then institutions and enterprises are still having a hard time entering the space. They have trade secrets. They have essentially information that they have to keep confidential. And then lastly, there are just a lot of use cases that wouldn't make sense without any confidentiality. So you can think of the card games, private voting, blind auction. So we utilize a cryptography called FHE. That stands for fully homomorphic encryption. By show of hands, how many people have heard of this term before? Okay, great. So for folks who are non-technical, the idea is that you can encrypt data, but also compute on top of it without having to decrypt. So when you apply FHE to the EVM, what this really means is that you get to have encrypted data types, but also encrypted operations, such as additions, multiplications, divisions. And we recently released a research paper with Circle on this topic of confidential ERC20 framework. And so the finding here really is on 3 points. One is on the flexibility of the decryption rules. The second one is on composability, which I'll mention a little bit more, talk a little bit more after. And then lastly, it's around this idea of programmable transfer rules. So the idea of composability here is with this basic primitive, a confidential ERC20, you are essentially able to build other things on top. So imagine being able to leverage the confidential amount and then cast a private vote, or use it for private payments, or use it for private lending. We are actually utilizing a couple of different cryptographies to achieve this. So, Inco really is a combination of MPC, ZK, and FHE. These three cryptographies are utilized for very different purposes. So MPC here is only used for decryption. And so essentially there is a private key and public key pair that is essentially encrypting this entire system. But this private key never exists because what's happening is this MPC network generates this key through distributed key generation. And so you can think of this having as its own network. Essentially, if you need to decrypt something, every single node needs to do partial decryptions and then to recreate the plaintext, right? And then on the compute side, we're utilizing FHE, which allows you to do state transitions over encrypted data without having to decrypt. And then lastly, the ZK part is to make sure that every ciphertext is not malformed, and then that the user also knows what the plaintext is, because else someone can just copy paste your ciphertext, deploy somewhere else, and then decrypt it, right? So with this, we actually believe this is the next frontier. It's the next frontier because you are now able to enable new use cases that weren't possible before. So if you think about gaming, there are just a lot of new types of games that you could be enabling with confidential compute, asset management, DeFi, and also infra. So just a couple of examples, right? So in terms of confidential ERC20, this is probably the most basic example, just to explain what you can do here. Today, your balance is completely transparent. It's just a mapping of address to a plaintext integer. What if you want to hide your balance, right? So this is where having a encrypted data type like EUINT allows you to hide your balance. So here, I can directly encrypt the amount of money that I have. And when Bob sends money to Alice, what you're sending essentially is an encrypted amount, right? So this, you can see here, there's the EUINT64. What's interesting about this is, the flow of funds is actually visible. It's only the amount that's being hidden. So it's very similar to Venmo or Revolut, that experience that some folks might be familiar with in Web2. And how does this work, right? How are you able to transfer a confidential amount without actually knowing what it is? So this is where you can actually write conditionals over encrypted data without actually using like a typical if-else statement. So the first line of code here, you're checking if the amount you're transferring is less than the user balance. And so you do this over FHE, where by doing tfhe.le, standing for less than or equal, you get an encrypted Boolean that basically could be true or false. And this is what you get is this variable can transfer that you pass it into this conditional multiplexer. So what this is really is you can think of an alternative to like an if-else statement. If the condition is true, you will return the encrypted amount. If it's false, you will return the encrypted 0. But from the outside perspective, transfer value is going to be encrypted, right? So now what you do is you add this transfer value to the recipient total amount, and then you also subtract it from the sender. So if the value is 0, essentially nothing happens. You just end up transferring 0. If the value is correct, then you end up transferring the actual amount. So another big use case here is also in gaming. If you think about today, there's no fully on-chain poker game. The reason why you can't do this game is because poker is a bluffing game. Without confidentiality, this game would basically make no sense. And so with FHE, you can actually generate a stream of randomness over encrypted bits. And so this is where you can call a simple function that generates additional basically integers that are hidden by default, right? So this is something that Chainlink would not be able to provide because your typical VRF is plain text, but here you need to have a confidential integer here. We actually built this game roughly a year ago in New York, actually at ETHGlobal as well. And this is a fully on-chain mafia game. So another name for this game is Werewolf. The idea of this game is that you can have a secret killer, detective, doctor, and villager. And it's a bluffing game. Basically, if you're the secret killer, you have to pretend that you're not the killer throughout the entire game and try to last as long as possible. And the role of the other players are to basically figure out who this imposter is, right? So here again, because you can generate the hidden roles fully on-chain using the randomness, you can also hide the roles. This becomes super easy to build. And also this is a multiplayer game, so using FHE and it becomes a lot easier because you can use the blockchain layer as the coordination layer. If you're to try to build this game using something that's more off-chain based, maybe like ZK, it would become a lot more complicated because then you have to build off-chain tooling. You have to think about state coordination across multiple players. But here, because everything happens on-chain, we built this in less than 30 hours. So yeah, if you think about games today in crypto, they could actually be a lot more fun than they are today. And this is because if you think about all the game mechanics that exist in Web 2 that actually make a game fun, require some kind of hidden information, right? So either I have to hide the player stats, the amount of gold that I have. And so here you can imagine a new game mechanic where the player stats are actually hidden. And so if you trigger some kind of battle mechanism, you can multiply the player stats by some kind of on-chain randomness and settle the battle, right? So this is where for us we do think gaming is a very interesting vertical here that we can definitely expand and just have people build novel primitives and game mechanics. Identity is another one. The reason why it's also very impactful is because today all the DIDs are completely static. You KYC with someone like Binance that will basically send you a soulbound token that says, okay, you're over 18, you're in Europe, you have a good credit score. However, this is all public, right? What if you don't want all this information to be public? So what you can do with FHE is what we call dynamic DID, which the idea is I can actually encrypt your credit score and store it directly on chain and selectively reveal information. So the reason why you can do that is because with FHE, you can also do comparisons, right? So you can do a FHE.greater than. So I just want you to know that I have a credit score over 700 and nothing else, right? And this credit score can change over time, right? So it makes sense to have a identity layer that gets updated and where people can query different insights, and this insight could change over time. So other examples could be your geographic location, your age, and this is very similar to how Web 2 works, right? You use your Google Auth to connect to different applications. You say, I want you to access my contacts, but not my Google Drive or my calendar, right? And this is kind of like missing user experience that we have in Web 3, which everything is public. But what if, for a casino dApp, I just want you to know I'm over 18, all these other information should remain private. DeFi is very interesting because in the case of a private AMM, if the amount you're trying to swap is hidden, essentially nobody can front run you, right? Because they don't know, necessarily what the slippage would be and what the arbitrage opportunity could be, right? I mean, they could try it, but they're taking a lot of risk by trying to sandwich attack you. So, you do get MEV protection by default. And I would also say, I would urge people to think about other novel DeFi mechanisms. So let's say, confidential lending, where, today there are attacks where if I know you can be liquidated by manipulating the price, I can actually do it, right? But what if you hide the liquidation threshold? Then, it makes it a lot harder for a hacker or attacker to basically try to gamify the system. And so this is actually a problem that actually happened in the past where, people will manipulate the price oracle to get whales to get liquidated, right? So, there could be more interesting things you could do here around private DeFi. Private voting is a very good example of how, a shared private state is useful. Here, when people cast votes, they directly interact with this smart contract layer. There is composability. There is the ability for you to directly, cast a vote and do the tally directly on chain. And again, if you were to do this, using something like ZK that happens off chain, then it becomes a lot more complex to coordinate the states. And because ZK cannot do state transition over private data, there could also be information leakage. So we are compatible with existing Ethereum tooling. If you are a Solidity developer, you can get started within 20 minutes. So you can use Hardhat, Remix, MetaMask. And I would say, for anyone who has experience building Solidity, all you really have to learn are the new syntaxes. And also this slight different way to write conditionals, which is, select. And we support a pretty wide range of operations, comparisons. So you can do divisions, you can do right shift, left shift, bitwise operations. And it really means that you can build a lot of things beyond just simple payments. If you want to build DeFi, gaming, it's really up to you to unleash your creativity and then create novel primitives and also experiences for the end user. Just from a high level, the way this works is, there is a JavaScript library where you encrypt data, all the inputs. And so the way data is encrypted is called ciphertext. So you have data padding, some data, some noise padding, and some noise. That's sort of the structure of the ciphertext. So you generate that on the front end, and you pass this on chain as an input param. And then from there, you can cast this into different types, like an EU8, 16, 32, 64, encrypted address, or encrypted Boolean. And so we have a 10K bounty. There are 3 tracks. One is open innovation. So here we're very flexible. If you can come up with novel primitives around DeFi, identity, governance, this is kind of what we're trying to push people to explore. And then it is pretty greenfield opportunity because these primitives don't exist over FHE, and so there is an opportunity for you to be the first one here. Second is around confidential DeFi. So like I said, AMMs, lending, if you want to try to experiment with flash loans, dart pools, the idea of private DeFi, I would say, is still very much underexplored, so there could be a lot of opportunities here. And lastly, gaming. So there could be a lot more games that you can build now. Some examples of previous games include fully on-chain Risk. So that's like the bluffing game where it's more strategic than bluffing. So essentially you have armies across a map, and you can only see your enemies if you're nearby a certain border, right? Or for example, the Mafia game that I explained earlier, that could also be one of the novel type of games. People have built, let's see, Hangman, simple guessing game. So there's just many new games that you could be building. And lastly, you do have a chance to be part of our Builders Advocate program. We'll have a booth somewhere in the venue, and then definitely come talk to us. We're happy to provide you feedback on your idea, and then our team members are also here to help you debug if you have any problems. And so you can find our documentation here. We have a couple demos on this arcade page, and we also have a Discord channel here, and we do have a hackathon channel. So if you need any support from on the technical side, definitely ping us. And yeah, that concludes the workshop.